Right, so now we're going to look at the idea of volume, and we have three dimensions here with volume. We have the length, the width and the height. So the length, if you like, gives us this distance across the top here, and then this width gives us this distance here. And then effectively what we're doing is we're then bringing in this third dimension, which is the height. When we're going to calculate the area of a volume, it's length multiplied by width. So length multiplied by width. So that basically gives us the area of this top section here. And then it's basically like it's how many of those are stacked on top of one another is the multiplication by the height. So it's length times width times height. So L times W by H, which will be represented as LWH on our formula sheet. So let's look here at our rectangular prism here. It's got dimensions on it now. So the length is 4 centimeters, the width is 3 centimeters, and the height is 2 centimeters. So we can take that information and put it underneath our rule here for volume, which is length, 4, multiplied by width, 3, multiplied by the height, which is 2. So 4 times 3 is 12. And as I've done in the past, I sometimes note take like that as I'm doing things. 4 times 3 is 12, times 2 is 24, and it's centimeters. And this time it's cubed because we're dealing with a volume, so it's a cubic measure. All right, so this time we're given a rectangular prism that actually has some markings on it as well. So it's telling us that this 10 meter width is also the 10 meter this 10 meter length is the same as the 10 meter width. So you've got to take note of those markings. So now we know that this one is also 10 meters. And as I've said in the past, marking these things on your diagram can help you connect more strongly with that information. So here it's 10 multiplied by 10 multiplied by the height, which is 1. And so that's obviously going to 10 times 10 is 100, times 1 is also 100. So it's 100 meters, and it's cubed because it's a cubic measure. All right, now we have this rectangular prism with a rectangular prism shape cut out of the middle of it. So this question is really asking you to find the area of the remaining shape. So so the suggestion here is to find the larger rectangular prism volume. Let's call that A. And then we're going to find the volume of the whole, which will be the smaller rectangular prism. And we're going to subtract that A, take away B, and that will leave us with the volume of, let's say, the remaining shape is how we're going to solve that. So let's do A first. So A is going to be the length, 10, by the width, 4, by the height, which is 4. Okay, so that's our first thing. And then we're going to take away from that this inner part here. So the length here is 5. The width stays the same for both shapes. So we can use the measurement from out here to do the measurement in here. It's going to be the same. So it's going to be times by 4. And then that's going to be multiplied by the height, which is 2. So we end up with this 10 times 4 is 40. 40 times 4 is 160. Take away 5 times 4, which is 20. 2 times 20, which is 40. 160 take away 40 is 120. And we're dealing with meters cubed. That's going to be the volume of this outer shape here.